In the previous example, we talked about bar charts for qualitative variables. Right? We did an example where we had a bunch of students whom we grouped by major and then used the information to construct a bar chart. Let's now look at something called a histogram. So a histogram is just a bar chart for a quantitative variable. And we mainly use the histogram to show the shape of a distribution. Let's look at an example. What I have here is a data set with 30 observations. The value of the lowest observation is 0.035. The value of the highest observation is 0.969. So to be able to draw a histogram, the first thing I want to do is I want to construct a frequency distribution, which is what I did in my in the first table here. Basically, what I did was I divided my data set into 5 intervals. Right. Each of which has a width of 0.199. So this table tells me that there are 2 observations whose values are between 0 and 0.199, 6 observations whose values are between 0.2 and 0.399, and so on and so forth. I then use the information to construct a bar chart, which is what we call a histogram. Note that this histogram is a perfectly good representation of the data, right? But let's see what happens if I have 10 intervals instead of 5. Then what I have is the second frequency distribution here, where I have 10 intervals, right? And the corresponding histogram. Note that they now give us more information about the data. For example, from the first histogram, we know that 9 observations are between 0.8 and 0.999. But the second histogram tells us that 7 of those observations are between 0.8 and 0.899, and only 2 are in the interval from 0.9 to 0.999, right? So having more intervals gives us a better idea of how the data points are distributed. Now, these intervals are typically called bins. So in the first frequency distribution here, we have 5 intervals corresponding to 5 bins. And then in the second frequency distribution, we have 10 intervals, so there are 10 bins. Now, with that information, we can go ahead and define cumulative frequency. So cumulative frequency is the total number of observations whose values are less than or equal to the upper limit of a bin. So let's go back to our data set from before and see how we can construct a cumulative frequency distribution. Okay. I'm going to do it for the first frequency distribution here, and you can follow the same procedure to do it for the second frequency distribution. So what I will have is I'm going to have two columns. One column for the value, and the other column for cumulative frequency. So let's look at the first bin. The first bin has an upper limit of 0.199, right? So we have less than 0.199. We're asking ourselves how many observations in the data set are less than 0.199, and the table tells us that there are two, right? So we put 2 here. Okay. For the second bin, the upper limit is 0.399. So again, we're asking ourselves how many observations in the data set are less than 0.399. And the answer is there are 2 plus 6, which is 8. Okay. 2 observations between 0 and 0.199, and then 6 observations between 0.2 and 0.399. So for the third bin, you're going to have less than 0.599. That gives us a cumulative frequency of 2 plus 6 plus 8, which is 16, right? So 2 observations between 0 and 0.199, 6 observations between 0.2 and 0.399, and then 8 observations between 0.4 and 0.599. Okay? So if you keep doing that for the other 2 bins, you're gonna have less than 0.799, and I'm not gonna go into details here, but you should get 21. And then for the last bin, less than 0.999, you're gonna have a cumulative frequency of 30.